Hello, Math Humans. We're going to do 5.7b today. We're going to be doing more work with our arc-trig integration. So our objectives are that we're going to do a few more arc-trig integration problems, and we're going to add a new twist today. So the new twist is completing the square. Woohoo! And we did this in pre-calc. You did it in Algebra 2. So we're just going to go back and review how to do completing the square because it's going to add a new dimension to our arc-trig problems. So let's say I had the equation x squared plus 4x plus 7, and I want to factor, technically it's called factoring, using completing the square. So I'm going to rearrange it a little bit. I'm going to write 4x, and then I'm going to scoot the 7 over. Half of 4 is 2, squared is 4, so I'm going to do plus 4 minus 4 because the net effect has to be 0, so of those two terms. So now I can factor because this is now a perfect square trinomial, so I'm going to do x plus 2, quantity squared plus 3, and then I factored. Okay, so that is what, and notice now it looks like an arc-trig integration problem. So now we're going to try just one more, make it be a little bit different. So what if I had 2x squared plus 4x plus 7? Okay, same basic problem, but now I have a leading coefficient. So I'm going to factor a 2 out of the x squared and the 2x. I'm going to leave some space, and I'm going to push the 7 out of the way. Now half of 2 is 1 squared is 1. And then now I distribute that 2 times 1 and I subtract 2. So I'm going to do 2 times x plus 1 quantity squared plus 5. So completing the square generates a perfect square binomial. So then I can go ahead and use my arc-trig problems. Okay. So let's jump in with an example. So example number 1. I'm going to have the integral of dx over x squared plus 4x plus 7. Shocker, we've seen that somewhere before. So because we've already done this, I can't do arc-trig because it's not in factored form, so I'm going to use the work that I already did. So I'm going to rewrite my integral as x plus 2 quantity squared plus 3. So now my u is going to equal x plus 2. My du is dx, so I have this piece. My a is going to equal the square root of 3. So then this appears to be du over u squared plus a squared. So this is 1 over a arc tangent of u over a plus c. And then I just fill in all of my information. So I have 1 over radical 3, and then I have arc tangent of u, which was x plus 2 over a radical 3 plus c. So my integral of f of x dx was going to equal my 1 over radical 3 arc tangent x plus 2 over radical 3 plus c. So completing the square allows us to do some additional problems using our trig substitution, not trig substitution, or trig integration. Trig substitution is way more fun. That comes in Calc 2. All right, example 2. So I want to find the area of the region bounded by the graph of f of x is equal to 1 over the square root of 3x minus x squared, the x-axis and the lines, x is equal to 3/2 and x is equal to 9 over 4. So if you put this in your handy-dandy grapher, and then you have your two vertical lines, your region that you're going to take the area of, so if this is 3/2 and this is 9/4, here's going to be, it's kind of a flat-looking curve. This is going to be what I'm actually trying to take the area of. So my area is going to equal the integral from 3/2 to 9/4 of 1 over, and I'm going to write this as the square root of a negative x squared plus 3x, okay? So I'm going to take this piece out, and I'm going to do completing the square on it, and I'll do that right here. So if I have a negative, and I'm going to x squared minus 3x, leave some space. Half of 3 is 3/2 squared is 9/4. This is a negative 9/4, therefore this is a positive 9/4. So here's the negative. This is going to be x minus 3/2 quantity squared plus 9/4. So I'm going to rewrite this integral again. So it's the integral from 3/2 to 9/4, and I have 1 over, and I'm going to write the square root of 9/4 minus x minus 3/2 quantity squared, and then there's my dx. Ooh, and my bad, I didn't put a dx in up there. So now it looks like the arc sine, okay, so it looks like arc sine. So I'm going to have a as 3/2. My u is going to be x minus 3/2. My du is dx. So I don't have to introduce anything else into the integral. So now this is just the square root of a squared minus u squared. So this is going to be my arc sine of x minus 3/2 over 3/2, and I'm going to evaluate from 3/2 to 9/4. Okay? Alrighty, so far so good. So at this point, I could flip this over to make my evaluation easier. So I could say this is the arc sine of 2 times x minus 3/2. I just flipped the bottom fraction over 3, and then I'm going to evaluate from 3/2 to 9/4. So kind of 6 of one, half a dozen of another as far as easy. It's just messy. So this is going to equal the arc sine of 2/3 times 9 over 4 minus 3 over 2 minus the arc sine of 2/3 times 3/2 minus 3/2. Okay, alrighty. So 3/2 minus 3/2 is 0, and so this whole piece becomes the arc sine of 0, and that says what angle has a sine ratio of 0, and sine is 0, right there. So this whole thing is just 0. So now I have the arc sine of 2/3 times, I'm going to multiply this guy by 2 over 2. So I have 9 minus 6 is going to be 3/4. The 3's cancel. So this is going to be the arc sine of a half. And remember, sine is a half, 1, 2, when this is pi over 6. So my area, if I write this down, that seems a little anticlimactic, from 3/2 to 9/4 of f of x dx is pi over 6. Alrighty, that's it for today. I will see you soon.